First of all, thank you for having me. I thank Core Studio and Charlie for having me here and everybody in the audience here. Thanks to New Balance for supporting my computational design wanderings inside and outside the company. And thanks to everyone actually who presented today, because it's amazing that I get the chance to talk now, like everybody just paved the road and gave the torch to me. Hopefully I'm not gonna burn myself, but kind of like try to use a torch to kind of like shed some more light into the discussion, especially in terms of machine intelligence and human intelligence and the relationship of human to the computer and to the design and their kind of like interdependent relationship. So the title is Parts for Wholes because, you know, we have been seeing lots of amazing images, designs, and so on and so forth, and including ourselves, we kind of like interpret everything. Either they are really made of parts or as if they are made of parts, and then we try to kind of like make a sense of the total situation, which might be a kind of like a condition, state, or design, right? So we are going to investigate this idea and see what kind of like parts and wholes can do for each other. So a very simple question, stepping back and saying, okay, is the dot inside the closed curve or not? So our parts are a dot and a closed curve. And the whole is a total situation of the condition of being inside or outside. So when I ask this to you, as we heard, maybe it takes like 30 milliseconds or less or more to kind of like give you the answer because you use your perception. But if you need to instruct this to a machine, this is one of the methods that you can use, which was developed, I think, 30 plus years ago. So you should race from the point and you count the intersections with the closed curve. And at the end of the day, if you have odd number of intersections, it's inside, even number of intersections, it's outside. What's interesting here is that the problem of seeing becomes the problem of unseeing, right? So you make the machine unsee to give you the answer. So then the question is, when we say intelligence and talk about artificial or machine intelligence, is it really the same thing with the human intelligence? It's a pretty kind of like interesting question. So you try to simulate the human intelligence, but you use the tools of human intelligence. So these questions, I've been looking into them maybe, I don't know, like before 2006 as well, but my background is in architecture, computational design. This is one of the projects just to kind of like start a discussion, you know, lots of facade designs around that time, right? So it was interesting. And I was lucky enough to start the KPF's computational geometry group at the time. So I was interested kind of like executing designs, but also kind of like making the group produce these kind of like pseudocodes to explain the kind of like quote unquote logic behind the script, how it worked. And one point maybe I'm going to kind of like point out to is that like red circle on this side, on the right-ish side. Every panel is, again, quote unquote, aware of the neighbors. So we were trying to kind of like develop the script, so make sure that every panel is placed, cut nicely, put in place, and they're aware so you don't keep repeating the same kind of like panel in the same location so the design doesn't get boring. Okay, nice idea. Guess what the program produced? It produced things and the designers didn't like it. So we ended up putting other circles, the smaller ones. It's like, okay, if you don't like that line, just go and click that circle. And that circle was literally in Rhino. So you could click it and it would kind of like redesign that level immediately for the designer. So it was kind of like running the script, getting something and just clicking the bunch of buttons and maybe be satisfied at some point. So that's kind of like, looking at the parts and trying to arrive at a whole with using the machine, but also using the perception. Again, like similar project from the same time. So like parametric and generative design, I think I've been doing a lot for designers. And it was hype at the time, and now probably not anymore. It's just kind of like became mainstream. But I think it was an interesting time to understand that, okay, the reality requires some sort of kind of like, assembly. Although we were working with these kind of like forms and flux, you had to kind of like split them into pieces and put them together. And this model has like lots of parts that were digitally manufactured, including Charlie's kind of like fingerprints on them too. So that was the part of the process as well. But on the flip side, you can use similar technologies to kind of like visualize the vision, right? So this was another model that we produced. Both models were exhibited in SIGGRAPH in West Coast. And then it's pretty interesting because you start with parts, you arrive at something, and at the beginning of the process, you have a vision too, and the vision doesn't have any parts at all. So everything becomes an aesthetic statement. So the question is, how do you deal with this thing? Is it architecture? Is it the vision? Is it the image? Like, what are we really trying to achieve here? So that was my question before joining the KPF, which was about like computational aesthetics. So I was trying to make the machine render the images that I would like to see. And it wasn't kind of like conforming into one kind of like taste. You would feed images to the computer, the ones that you like, and it would kind of like discretize the image depending on the composition and the tonal distribution of light, and understand, again, your like, and then produce images like that. The question here is, okay, this is a pretty big problem. I don't think it's solved. It's not going to be solved, and if it is solved, it doesn't matter. So this is my take now. But the problem is an interesting one because it's like how you split the world into pieces and how do you put things together. And this is a very basic problem about like seeing, about building things, about architecture, and so on and so forth. So there's an answer in this book. So Persik talks about the analytical knife, right? So everybody has an analytical knife looking into the world, and you use your knife to kind of like split things into pieces, and then you make sense of it. You name, okay, this is A, B, C, D, and you put things together, and it all makes sense. But what's weird is that everybody's analytical knife is different, right? So probably there are people who agree so far with me, and some people that, oh, he doesn't know what he's talking about. So that's totally fine. But at the end of the day, to discuss, we have to stop. We have this moment, and we have to have descriptions. Like, we have to stabilize the world so we can make sense of it and talk about it. But there's a problem with the descriptions because, you know, there are multiple descriptions for the same thing. When we talk about an engine, for instance, you can talk about the working principle, right? Or talk about the parts and how to put them together and try to maybe get a patent for that. Or you can describe it as an airbrush painting, or kind of isolate a part of it, render it, and it becomes an artwork, right? But interestingly, actually, the world is even bigger than that. So this is an engine too. So what's really powerful for humans is that, like, you can have many descriptions, but you can still arrive at another one. So that's why, like, when Toro said, like, AI is about reading patterns, it's fine. You know, you can read patterns, you can pick things, and you can combine patterns. But there are moments something emerges that you kind of like, that's not really coming from the pattern necessarily. So that's the strength of being human. And if you stop and think about like different ways of describing different things, for instance, there was a moment in physics, you know, when after they discovered the particles, they are like, oh, hey, okay, we are talking about electrons, but we cannot really talk about electrons without the field because it doesn't exist without the field, right? So these things coexist and you have to talk about them together. It's the same for the human condition, which is like mind-body duality. We talk about mind, soul, body, and so on and so forth. But show the line to me with your analytical life where my mind ends and body starts and so on. So these are kind of like truly united in reality. Or you can kind of talk about a drawing. We saw a lot of drawings today, digital drawings, but I can define a drawing as something that a tree makes when the wind blows, right? So this is Tim Knowles, an artist from UK. This is Tim Engel, an anthropologist who defines our life on Earth, saying that, okay, we are not the inhabitants of the world, but exhibitants of the weather world. So it's the difference between the diagram A and B should be kind of like obvious. These things kind of like just rethinking the descriptions we just take for granted would change, I think, the way we understand things. So you may end up at a point like this, in which you start thinking about, okay, can I make computation without describing things? Because when I describe, I kind of like isolate things and I limit my world, so I cannot really expand. Actually, it's possible, right? So this guy is George Stinney. He's the founder of Shape Grammars. And these two squares, he says, okay, I can look at that and I can define it as 4 triangles or 2 squares, and actually they merge when they kind of like build this non-hierarchical system. And there's a frame behind him. Those 2 paintings happen to belong to my research. I'm lucky that he has them there. So my question is, okay, how can I talk about this oil painting in terms of computing, right? And I'm not talking about kind of like AI producing paintings or, you know, kind of like oil-like paintings and so on and so forth. Those are achievable, and we saw recently, you know, a painting was sold for $400-something million, yes, 2 days ago, I guess. The thing is, when you look at something like this, can we relate our understanding of design and art and computing in any way possible? So this was my proposal. So it's okay, let's try that. So let's start with a shape, which doesn't have a definition, description, clear, and then we capture it, and then we project that the same thing, a pattern that kind of like emerges from that drawing underneath the drawing, and then we keep tracing. So this is like patternless pattern, because what happens that you have the pattern, but it's there for you to trace. So it's not kind of like exactly the same thing, but it's kind of like this fuzzy, again, if I can use the word, world that you can kind of like look and pick and choose stuff with perception. There's something very interesting about this process, because you keep going, and there appears a moment, circles, like the painter put circles, which weren't there, which were not in the pattern, but they were maybe suggested by the curvature of the other lines, but which are kind of like not necessarily right there as they are as a pattern, right? So that's kind of like the human understanding and arriving at a description, I would say. Quickly, another drawing, so I can take this drawing, and actually this is computed. So it's a drawing that's hand-drawn, and it's computed by using the same system. And retrospectively, I can explain this as a calculation. I put a shape, you know, I make a pattern, I trace over things, and so on and so forth. The interesting thing is that red shape, which doesn't, again, exist as a kind of like self-standing entity, or which wasn't the seed, which was like never, it's not there as long as you see it and you trace it. Okay, so this is the short story, long story short, and it becomes the central piece of that drawing. This was from my PhD research, and there's the setup. Sorry, it's kind of like the projector is not too great for this, but there's a projector beneath, there's a drawing surface, there's a camera, and this is an on-diagram of the system, because I didn't want to diagram it out. It's very open. You just kind of like keep drawing, and then you use the computer at the same time to generate and move those patterns. And the machine doesn't do anything. It doesn't interfere. It doesn't try to understand the shapes, makes things out of them, and so on and so forth. It's just the kind of like the tool that you use to expand your own drawing and wandering. And again, this dissertation is available online if you're interested in seeing more of that. So this all goes back to this kind of stuff, again, about the description. So the big question is this a duck or a rabbit or both? Right, so this is the Gestalt switch, like psychological switches that, again, Taru was kind of like talking about. But my point is that, okay, actually there's an alligator there, right? And you have to see it. That's my claim. I have to see it. This is what I'm thinking, to kind of like, if you're going to make things better as designers, as construction companies, as teachers, we have to see the alligator and more there. So that's my kind of like a point. And it doesn't end with 2 descriptions, so you have to come up with 4, 5, 6, and make your system open enough to kind of like use and utilize all these descriptions. But of course, it's like, okay, what is this guy talking about? Like, you know, we're computing, and we need symbols, we have to name things, we have to kind of like have goals, and so on and so forth. So the ambiguity is kind of indispensable for design at one end, but at the other end, it's kind of like obstacle for computing. So, okay, what are we going to do about it? So this was the moment when I kind of like got a call from New Balance, as I was kind of like fighting with these questions for like 10 plus years. And it's a pretty interesting environment, and they're kind of like pretty invested in both like design as an open-ended search, but also they're invested in data design efforts. So these images were kind of already there before I started. When they presented a challenge to me to kind of like do something with their data, pressure data, what I ended up doing was, because maybe I was just a PhD student at the time, I was like, okay, let me explain you what you're asking me. So that's what I did with them. So when you collect data from around here, the pressure data from the insole and outsole of a runner is being collected, right? So there's a lot of abstraction. You get numbers from there, you get like there's pressure, bunch of stuff happening, but it's a big total situation, and you're kind of like looking at a very small portion of it, trying to make sense of out of that. And then maybe in the next step, you make an interpretation and you kind of like design something in regard to what you learned from the process, right? So these are the numbers that I got on that side, there's like your left. And then on the other side, on the right side, this is like, okay, I parse and process the data, and then we kind of like get the total situation of the runner to the feet and then to the pressure, and then discretize to the numbers, like split the world, just keep splitting it. And then one moment we are like, okay, let's kind of like map some sort of like form onto that data. So that's kind of like pretty much mapping, which is algorithmic design, and you arrive at something, right? So this was one of the first images. I'm like, okay, so I can map a lot of stuff onto this thing, but none of them are answers, right? So it's more like, what is more interesting for me is that this is a field of opportunities, very open, and there's a high probability that whatever we do, it's gonna be wrong, right? So that's because we just kind of like, shrink the problem to a point that you can kind of like incrementally, do some kind of like better performing stuff, but you can never have a paradigm shift, and I'm going for a paradigm shift, right? So that's my interest. And nicely, again, like a slide, it's like always in beta. This is New Balance. It was there before I arrived there, so it's always like motivating to see this. And then my interpretations of, okay, like I can keep kind of like producing these kind of, let's say, forms, digitally manufacture them, test them out, look at them, decide what looks good and bad, what performs or not, and so on and so forth. But as always, I think it's interesting to we can kind of like keep going this way forever, fine, and there are kind of like a lot of people doing it, and a lot of people kind of like adding into this wild world of like generative and computational design. The question is, okay, what are the things that are still not working? And are we taking, or are the computer science took the right path to solve these things? Is the human mind really working in the combinatorial way? Or is it really working, or are the computers really wrong from the beginning, like this binary system of like ones and twos? What's gonna happen when quantum computing, kind of like picks up? Is it gonna solve these problems, and so on and so forth? So these questions, I think, have been there and will be there forever. And guess what? The question is not new. So this is my reading of Albert Dürer's Engraving from 1514, and this is called Melancholia I. He depicts his like soul mate in this engraving, and interestingly, he did this engraving. He said, like, what is beautiful, I do not know. And if you look at the situation, what's happening is that he's sitting, or she's sitting in there with all of the tools of computing around him, but indifferent to all of them, right? So you can kind of like you can see like measuring tools of time, and you have like a truncated solid, you have like perfect sphere, you have scale, and so on and so forth, but nothing is being touched. So I think I take that as a kind of inquiry towards computing, right? And then here is my Photoshop skills for adding a little bit of spice to Intel Inside, or AMD is doing great too for the last couple of years. Human Insight, so we have to kind of like work with that. So that goes back to maybe the questions that we had in the first session. Are computers gonna do this, do that? Does it matter? Maybe one of the questions, because eventually it's your perception, your understanding, your look that's kind of like now criticizing me or agreeing with me. So it's all about you, actually. Why is this important? Because whatever we see as like amazing, hype, AI, this and that is gonna be one thing under the bell curve, like in a couple of years. Because all of our wildest dreams about touch screens, computers, they are realized, and it's just a touch screen, you just use it, right? So what's important to think about is, I think, those red dots, which lay kind of like outside the bell curve. Doesn't matter if you're on the extreme, still you're under the kind of like the normal distribution. This is especially goes for designers, because I'm kind of presenting a very fuzzy and kind of like ambiguous world. But I think it's like, trying to shoot for those points is pretty important. and which is the field of struggle, right? This is a quote from Edward Hill, description of drawing. I'm not going into the specific of those kind of like the projects, but it's important to kind of like keep the struggle and not be satisfied with the tools and not to go with the hype. And I'm gonna end it there. Thank you.